Hi, this is part 3 of the BGA cloud flying endorsement and EASA Sailplane cloud flying racing training. And this part is about the flight training. We can do flight training in IMC or simulated IMC under the hood. But in our motor glider, we can't fly in IMC, so it's going to have to be simulated IMC under a hood, a vision limiting device. We can do this either using the turn and slip or the artificial horizon, and almost certainly we're going to do it using the artificial horizon. We've got a Dynon D1 which we'll come to in a moment. And what we're going to be doing is some combination of straight flight, turning, achieving and maintaining a heading, returning to straight flight from steeper angles of bank, position fixing using GPS and the chart, position estimating using dead reckoning. We've got a basic cloud escape maneuver and recovery from unusual attitudes. And we've got an advanced cloud escape maneuver on a nominated heading. So that pretty much is the syllabus. We'll add a little bit to that with a cloud break approach. Here's the Dynon D1 that we're going to be using in the motor glider. It, in essence, has similar features to most other electronic horizons that you will find. We've got the horizon, the ground, and the sky. This symbol denotes where the wings of the aeroplane. So this tells us whether we're level or not. Up here we've got a scale that tells us how much bank we have on, 10, 20, 30 degrees, with this little arrow at 45. And we can see here we've got about 2 or 3 degrees of bank to the left. And we have a pitch scale where this is 0, then 5, 10, 15 degrees of pitch up and down. We have a little artificial slip ball in the middle, which tells us whether the equivalent of our yaw string, except it works the other way around. In this case, we would need to move our left foot forward to kick the ball back into the middle to get it correct. We have a speed here, but beware, on something like the Dynon, this is a ground speed, not an airspeed. More sophisticated instruments that you might fly with, for example the LX9070 I have in my Shark, that will be an airspeed, but this one is a ground speed, so we can't really use this for flying purposes. And in here we have an altitude, and again with the Dynon, this is a GPS altitude, not a barometric altitude, unlike the LX. This is actually vaguely useful, but we wouldn't want to use it precisely for avoiding airspace, because it's not going to tell us quite the same thing. On the right here we've got a vertical speed indicator, and down here we have a compass rose, west 300, 330, and an indication of our actual track. And again, this is a track, not a heading. So these are, with this little Dynon, what we're looking at is things that a GPS can work out. So that's ground speed, track, and our attitude using the artificial horizon reference system inside the Dynon. But very neat little instrument. So let's have a look at the basics of the flying program. Cloud flying with an artificial horizon is highly preferable compared with the turn and slip, particularly on a slippery glider. Because it's a control instrument, it tells us precisely what the glider is doing. In the old days, when people flew wood and fabric gliders, maybe it was a reasonable thing to do to fly on a turn and slip, because there was a lot of drag. You couldn't kill yourself, because if you opened the air brakes, they were completely speed limiting. That isn't the case with a modern glider. And decent artificial horizons are now cheap, so let's use one of those. We're going to use something called a selective radial scan. Our primary focus is on the artificial horizon, the control instrument. And then we make broad inputs made with reference to that instrument, and then we look at the other instruments to determine what change in aircraft attitude and aircraft orientation we need. And then we make fine adjustments with the reference to the control instrument. And then we'll talk a bit about the basic stabilization and recovery maneuver. After that, we'll look at situational awareness. So let's have a look at a radial scan using the artificial horizon. Most of our focus is going to be on the artificial horizon. Just like if we were flying visually, we look at our attitude and we hold an attitude we think is going to do the right thing. Then we'll move our eyes over to the airspeed indicator and check that that's right. Then back to the artificial horizon. So if the airspeed indicator is showing something that we don't want it to, perhaps we're a little fast, then we'll select a new attitude on the artificial horizon and hold that. And then we can cross-refer with the altimeter, or possibly the vario, or possibly our map. But we're flying by focusing on the artificial horizon. We might look at the ball occasionally to check that we're not skidding or slipping. We can also look at the string, although that might get wet in a cloud and so might be less useful. Perhaps 2/3 of the time on the AI and the others one at a time, and then coming back to the AI. So that is a selective radial scan. If we've got a turn and slip, and I'll mention this, although it's very unlikely that we'll be doing much of this, we might try it to give you a feel for it. Same sort of scan is possible, except we're going to use the ball as well as the needle. So it goes ball, needle, airspeed, ball, needle, airspeed. And that's our primary scan. We're making sure the ball is in the middle, because if the ball isn't in the middle, the needle isn't going to read accurately. Then we need to make sure the needle is where we want it to be, whether that's in the middle or maybe in a turn. And then we check the airspeed is where we want it to be. And then we make corrections with the stick and then come back and see what has happened. And then occasionally we'll look at other things. So the thing that's replacing our artificial horizon, if we're flying on a turn and slip, is ball, needle, airspeed. And then the selective scan goes out to the other things. Turn and slip 3/4 of the time, the ASI is of secondary concern, and then the others one at a time, and back to the turn and slip. In reality, gliders don't have the standardized instrument layout that many powered aeroplanes have. Well, you'll find, particularly with older gliders, instruments scattered all over the panel, and we have to adapt to that. What standards must we fly to? Well, using a horizon, we're looking for headings within 10 degrees and airspeed within 10 knots. Now actually we'll be aiming for a lot better than that, but this is the old exam standard, and we ought to be able to do better. But sometimes if your attention gets taken to something else, you might push those limits a little bit. Turn and slip is more liberal, but it's more difficult to do. As far as turning is concerned, we need to keep the angle of bank within plus or minus 15 degrees. Again, we want to be a lot better than that. And the airspeed within 10 knots, again, better than that. On the turn and slip, we can accept small deviations in the rate of turn and airspeed within 15 knots. And then there's a couple of exercises to do. Position fixing, given a range and bearing to a point, which might come off a GPS if we're going to use that, and you need to be able to plot that on the map to within a couple of nautical miles of their actual place. And the challenge here is to do it while flying. We'll do a cloud break approach, and this, as much as anything else, is to show you how to do it and to be a little exercise to do that pushes the workload up a bit, and so make sure that you're able to do the instrument flying in the background and think a bit. And the scenario is we go on a wave flight and we get stuck above cloud. And we need to get back to the airfield, but miss the mountains, which tend to be in places where we go wave flying, because they've got cloud on top of them as well. You never know, it might be quite useful, but it's quite hard work. So what we're going to do is we'll come along at 3,000 feet QNH, and then we'll make a descent on a 12-to-1 glide path down to 1,000 feet QNH at some point, maybe Gransden or one of the waypoints close to Gransden. And at 60 knots, that's 1 nautical mile per minute, or 2 kilometers per minute. So 2,000 feet in 4 minutes, which is 5 knots down, or 1 in 12. And the way we do it is we come along till we're 8 kilometers, and then we start a 5-knot descent, and then do height checks at different distances. So at 8 kilometers, we're going to be at 3,000 feet, at 6 kilometers, 2,500 feet, at 4 kilometers, 2,000 feet, and so on. And meantime, we have to maintain the track into the airfield. Using an old style compass rose type GPS is a bit more tricky than having a moving map, and we'll probably be using a moving map. But say we're going inbound to Gransden on a track of 200. If we drift to the left, the bearing will become more than that, and we need to turn right to intercept the 200. If we drift to the right, the bearing becomes less, and so on. And if we have a piece of kit that tells us what track we're doing and what the bearing to Gransden or wherever is, we can keep those two numbers the same, and we will take out any effects of wind. So, for the flying program, these are the basic exercises we'll be doing across a number of flights. We'll start off by looking at straight flight and medium turns visually, just to remind ourselves of the basics of flying, and we'll look at the behavior of the glider during that, and in particular we'll look at its stability. So under what conditions the glider will remain pretty stable, certainly in yaw, mostly in pitch, but not in roll. We'll then have a look at the basic stabilization and recovery maneuver. We'll demonstrate the behavior of instruments, and then we'll work on and practice flying in a straight line, turning, maybe a little look at a turn lead on a turn and slip, position fixing and estimating, stabilization and recovery onto a heading, and the cloud wake approach. And we can expect a number of flights to cover all that. For navigation, mostly we'll be using a moving map GPS. We can use one of the Club UDIs, or if you have your own navigation system that you want to use, you can use that. But you need to be able to, when given a range and bearing to, for example, Gransden Lodge, show where your position is on a 500,000 map. So you need to know how to work out a reciprocal, so add or subtract 180 degrees from your current, from the heading that you're given. And you need to know how far whatever number of nautical miles is on a 500k map, based on the width of your thumb or the length of your thumb or something like that. The next thing you need to be able to do is to know how to get out of a cloud street. So we'll give you an exercise like you're flying along on a cloud street into wind on a heading of 200. How do you get out? And therefore you need to know how to add or subtract 90 degrees from that bearing. So 200 plus or minus 90 degrees. And that's a track that will get you off your cloud street. And you need to be able to work out how to estimate your position. So given an original position and a drift due to wind, where are you going to be? So That's all in the syllabus. It requires a small amount of mental maths in the air. Your brain's going to be quite busy because you're instrument flying at the time. Let's have a look at a few hints and techniques. If we're doing straight flight, make sure you're in trim. If you're in trim, the speed of the glider is unlikely to change very fast. And if you keep the attitude of the glider on the artificial horizon the same, the speed won't change. If it's all turning to worms, if it's all going wrong, stop moving the stick. It takes most glider pilots an hour or so of flying to actually calm down enough and stop moving the controls so much. You need to be very relaxed and generally make small movements of the controls when you're instrument flying. Keep the ball in the middle and use coordinated controls. It makes a huge difference. And then for straight flight, just use very small amounts of bank to make a correction. You basically have three attitudes to fly. A wings level attitude, which means you're on heading, or if your heading is a bit more than it should be, then you just need another attitude, which is a few degrees of bank to the left, and you just want a tiny amount of bank, which will slowly correct your heading to the right one, at which point you go back to wings level. But if your heading gets less than what you want, it's a few degrees of bank to the right. It's not big changes, it's small changes. For turning, you use the angles of bank appropriate to the task. If you're turning into a heading, a rate 1 turn is probably plenty enough, maybe rate 2. Only use 30 or 40 degree angles of bank if you're thermaling. And then take it, if you're trying to turn onto a heading, take the angle of bank right down before you get to the heading. Trim in a turn when you're thermaling. If the speed increases too much, then reduce the angle of bank and raise the nose. Most sailplane pilots bank too quickly and use too much bank. So gentle, gentle. And achieving and maintaining a heading, if you're trying to use a compass for that, you need to do timed turns. So we'll demonstrate that. But if we know what heading we're on, if we know what heading we want to turn to, we can work out, divide the difference by 3, and that gives us the number of seconds we want to turn on a rate 1 turn. If we're using a GPS track or track line to turn, remember that it lags, maybe by 30 degrees or so. So we want to reduce the turn rate quite significantly as the heading comes up. When you return to straight flight from a steep turn, if you've been established in a turn for a while, when you straighten up, it will feel as if you're turning the other way. So trust the instruments and don't forget to retrim for straight flight. For position fixing, ensure the GPS waypoint is set to the right thing, perhaps the airfield. You'll get the range and bearing to the waypoint. So then on the chart, in the opposite direction, measure the distance, and that'll give you your position. Make sure your thumb is calibrated. For dead reckoning, you have to work out the wind and then just use some simple approximations. So 15 knots of wind is a mile of drift every 4 minutes. Probably a good assumption that you've got 60 knots of airspeed, that's 1 mile a minute. So 3 minutes going north, then 4 minutes going west with an easterly 15 knot wind from a known position is 3 miles north and 5 miles west of your last known position. And you can just use the cardinal points, north, south, east and west as approximations. And then 20 minutes thermaling in the same wind, 15 knots, is a third of an hour, so it drifts you 5 miles to the west. So those are the sort of approximations you want to use. But if you're flying with a moving map GPS, this becomes a whole lot easier. The basic cloud escape maneuver which is the BGA recommended action if you've lost or are losing control. If the speed is increasing, don't wait until it's excessive. Initiate that maneuver at 80 knots or sooner. And the first action is to stabilize the glider. Put the stick central, hold it there, have full air brakes and at least neutral flap, and then wait for the glider to stabilize. Regain straight wings level flight if you've got an attitude reference. If you don't, wait till you can get visual and then decide what next. But go try it from various unusual situations in VMC in your own glider to convince yourself that it works. And then an advanced cloud escape onto a nominated heading. You need to have a plan before you enter cloud. If it's streeting and you head upwind or downwind, you might not exit for a while, so you need to be able to turn to one side. And you need to take wind, terrain and airspace into account before entering cloud and prepare your escape heading. For the cloud break overhead away point, which isn't actually in the syllabus, but we're going to take a look at, we can use the GPS, and we want a sensible height to arrive, let's say 1,000 feet. At Grandson on the QNH, if you're in the mountains, you definitely need to take into account the height of the ground. A 1 to 12 descent is probably a good rate. It's 500 feet per nautical mile, which is 5 knots down on the variometer. And you can monitor the progress every mile to see if you're on the right vertical path. If you get there too high, you can circle down, but watch out for drift if you do that. And next, let's go flying.